Okay, anytime.
Good afternoon. So let's take a look at this person, Stephen Hawking, a very famous scientist in the world. However, besides his talents in physics, he's not as normal as we are. He's unable to move and control his own body, and therefore he cannot write or speak. This is very difficult for him to communicate with other people. But can we do something to help those kind of people who have ideas in their minds, but just impossible to share? So in the following 15 minutes, my teammates and I will introduce to you an innovation which may do a little help, the thinking reader. But before we tell you more on that reader, let me first tell you about why we got this idea. Human brain is very complicated and amazing. We use it to store memories and control our body. Its principle is simple. By emitting some nerve impulses to different body parts, then the body parts could be controlled and actions could be done. So actually, the human brain has got a lot of power inside. Therefore, we start to think that is it possible for us to control something that outside our body? Or even, is it possible for us to receive and record the nerve impulses that emitted from our brain? So we start to think about an idea. That's to connect human brain to computer, such that ideas in our minds can be shown on the screen. And that's why we have the idea of the thinking reader. With our thinking reader, the people like Stephen Hawking can have the way to express their feelings by just using the reader, although they cannot write or type or use an action to tell people about what they need. Or we may even know what our pets are thinking about. And this might be a new way for us to communicate with other people in the future, just directly using our brain, but no words or other action is needed. So in the following time, I will pass to Dixon, who will tell you more on the literature review part of our thinking reader.
Good afternoon. So imagine that if you are a creative thinker, there are a lot of ideas in your mind, but you are a person with oral and written difficulties. You can't communicate with others. What will you do? That means you can't be well educated. You can ask questions to the professor. You can answer the question to give feedbacks. Also, you can share your feelings. You can say, well, I'm happy today, or okay, I feel bad because I can't communicate with others. Even the one who you love standing in front of you, you can say, I love you to her. What a horrible situation. And the only thing you can do is keep silence. But fortunately, scientists have keep trying to develop a machine or technology to help those people. And when they design, when they consider the technology, there are two questions they need to solve. The one is how to input the ideas from the users. The second one is how to output their thoughts from that machine. There's an existing technology called EZ-keys. Actually, EZ-key is based on a technology called visual scanning. If a computer installs EZ-keys, then a software keyboard will show on the screen and a cursor will scan from across the keyboard by rows and columns. Then a letter is selected by the movement of users' cheeks, and the movement of cheeks will be detected by a switch. So a word or sentence will be built up. The Hawkins is a user of these EZ-keys, but although it use it to deliver lectures or give a presentation is quite boring because spell words always spend around several minutes, so it's quite boring. It's okay if he is a professor, but for normal person, it's totally unacceptable. So we're trying to give another solution to this situation. So we have a new idea about how to create a new machines. Maybe I pass it to Matthew.
Before introducing the new design, let's look at how humans think. Once any thinking comes out from your mind, there are electrical impulses flowing through your brain. The electrical impulses code the information and they determine what you are thinking. Therefore, theoretically, if we can decode the electrical impulses, we can know that what you are thinking. Now, let me introduce the new design, thinking reader. It consists of two major components, a helmet-shaped reader and a computer with a translation program and a database. They are connected together by a wire, and from the bottom wheel of the helmet, you can see that there are many electrical sensors on the inner side of the helmet. Then, how to use the thinking reader? First, you need to switch on the power of the helmet-shaped reader and the computer. Then you need to wear the helmet. The electrical sensors on the helmet will record your thinking, record your electrical impulses. If any words comes out from your mind, that means the helmet-shaped reader will read your thinking. Then the data of electrical impulses will be transferred to the computer and compared with the database. Finally, the data will be translated and your thinking can be shown on the screen or read aloud by speech synthesis. Thinking reader can benefit the people with both speech and arm impairments in several ways. First, thinking reader take much less time to build up the words or sentences in your mind than the visual scanning technology. In visual scanning, it takes much time to select the desired letters, while thinking reader can read your thinking and translate it instantaneously. Therefore, people using the thinking reader can communicate and respond to others immediately. Furthermore, using thinking reader is harmless to the users. If you use the visual scanning technology, you will need to focus on the screen for a long time. It is very bad to your eyes and you will easily feel tired. In contrast, if you use the thinking reader, it is more comfortable even though you have to use it for a long time. One more advantage is that most people can use the thinking reader. If, for example, blind people cannot use the visual scanning because they can't see the keyboard. However, if they can still use the thinking reader, once the users can think, they can use the thinking reader, no matter what kind of disabilities they have. Now I pass the next part to Ivan.
Thank you, Matthew, for the detailed description of the thinking reader. Now, I'm going to talk about the feasibility of this design. The ultimate goal of the thinking reader is to convert the brain pulse to a word accurately and quickly. It is quite difficult because the human brain is a complicated organ which processes a lot of information simultaneously and continuously. This means when you try to bring up the word in your mind, your brain is also doing other jobs such as regulating your body temperature, sensing from the outside world, or even thinking something else. One of the ways to reduce this kind of
disturbance in your mind is try to stay focused on the word. However, it will require a lot of practice. After all, a powerful decoding model is required to convert the word to convert the electrical pulse to a word. First of all, a lot of research has to be done to analyze the meaning of the brain pulse and to create a database. Second, a powerful mathematical model is required to do the math. Furthermore, it requires a high-speed computer to calculate and to search for a word in a very short period of time. It means the thinking reader have to be connected to a commercial server through internet. Although there are so many constraints, the thinking reader is still a feasible design because we can get a lot of help from some existing technology. One of the technology is mind reading by brain scanning. It used the fMRI to scan the brain activity by detecting associated blood flow. The result is a 3D image of the brain activity which provides enough detail to reconstruct a picture in your mind. Let's look at the picture. The first row is the picture saw by the person, and the second row is the picture reconstructed with this technology. This technology can be employed in the thinking reader to reconstruct the word in our mind. A second related technology is the wheelchair driven by thought. In this wheelchair, in the screen, there are 4 boxes representing 4 directions, and they will flash in different frequency. When you look at one of the square, your brain will generate the same frequency as the square, and by detecting that pulse, direction instruction can be made. This can also be employed in the thinking reader to move a cursor to pick a correct word. In conclusion, we can use a lot of technology which is available already. However, the patent price would be huge, not to mention the production cost of the helmet and the running of the server. The thinking reader would be expensive. Let me pass to Tom.
So therefore, our thinking reader can really help people who cannot speak or even type. While comparing to the ESET key or some visual scanning, thinking reader is much more faster and is much more comfortable. And it is also supported by a lot of researchers. It could be expensive, but it is really worth it. So, thank you.
Very good. Very interesting idea. Thank you. I guess the big thing I'm just wondering is, how does the thinking reader interpret thought? What's the research on how does it take from the brain and turn it into some sort of electrical stimulation?
When you think of something, you generate a specific pattern of electric pulse in your brain. So if you do a lot of research to record what you're thinking at that moment and the specific pattern of electric pulse, then next time when you measure the same pattern again, you can correlate the pattern with a certain thought or certain image in the brain. So this device is reading the pulse and correlate the pulse with some word, and it can be generated in the screen.
Okay, good. Well, thank you. Okay.